Lesson 11.1, area of a circle. And as you're looking, you can see this is a foyer of someone's home, and it's a circular shape. So how would we go about finding how much material we would need to cover this floor? Let's go ahead and continue looking at the second slide. Luckily, we have a nice little formula that says area equals pi r squared. So one little hint, when you're walking, when we're talking area, sorry, we always refer to squared units. So if I'm talking length times width, I'm talking units squared. Same with circles, I'm talking about units squared. So remember, to find the area, we square the radius. So to keep this one straight from circumference, where it's diameter times pi, or 2r times pi, we are looking at pi times r squared because we're looking at area. So that's one way to keep those distinct and hopefully help you remember. So r squared is for area. So one of the real world examples that we have today is an epicenter for earthquakes. And it says the distance of intense shaking from the epicenter of a particular earthquake to the outer edge was 134 miles. To the nearest square mile, what was the area of intense shaking? So how much area was shaking? So first we're going to need our formula. Area equals pi r squared because we're talking area, so it's r squared. And we see the epicenter, and we know from here to here our radius is 134 miles. So let's see if we can figure this out. One little tip, if you're going to enter this into a calculator, you're going to want to make sure that you're using parentheses around whatever unit you are squaring. The calculator will not be smart enough to do it otherwise. So pi, or 3.14, times 134 squared. What do we get? Okay, so when I squared 134, I got 17,956. I multiply that by 3.14 for pi, and we get 56,381.84. So they said round to the nearest square mile. So in order to do that, I'm going to round that to the mile. So it's 56,382 miles squared. So that is how much area that everyone felt that shaking. Here's a quick little view if you want to pause to see it all neatly typed out. Otherwise, you can just continue to watch. We have another real life scenario, and that's the hurricanes. So in the fall is hurricane season for us, and we hear a lot of talk. Well, one of the things that's important is for them to measure the eye of the hurricane as well as the general diameter of the hurricane. And this will tell us a lot of information about the severity of the hurricane. This is actually a shot from space, and right here is the eye of the hurricane. So the diameter of the eye of the hurricane was 30 miles. To the nearest square mile, what was the area of the eye using 3.14 for pi? Okay, so I wrote it out as area equals pi times 30 squared. Let me just start all that over. Area equals pi times 30 squared. That is 3.14 times 900, which is going to be 2,826 miles squared. That is the area of the eye of this hurricane. That's just the eye. That's where there's nice weather immediately under it. This is all the intense weather. So that's a large area. We have another real world example. And this one maybe you've noticed if you've ever flown out west, but the farmers out there plant their crops in circular shapes. This is an irrigation technique that they do to conserve water. In the east, you'll see that we use squares. But when you fly west, you're going to start noticing that they use a circular pattern. And again, that's for irrigation, for water use. So let's compare two farms. One farmer has their crops planted in a circle with a diameter of 40 feet. One farmer has their crops planted in a circle with a diameter of 80 feet. I realize that these are small circles for farming. Justify why the field that has a diameter of 80 feet is not twice the area of the field with the diameter of 40 feet. Okay, so I set up the equations. For the first one, we have the area is 3.14 times 80 squared, and then the second one is 3.14 times 40 squared. And so we're just going to go ahead and square the diameters of these. And guess what? Do we do that? No, we don't. We square what? That's right. We square the radius. Let's correct that. Okay, so I went ahead and corrected it. Where did I get this 40? It's half of the diameter, right? So the radius is 40. Then I look over here and I took half of this 40 and for the radius and I got 20. So let's come down and see if I take 40 squared, I get 1600. And if I take 20 squared, I get 400. So over here I have 3.14 times 1600. Over here I have 3.14, the same pi, times 400. Now before I even go to the next step, because I don't really even need to prove that these are not going to be double or half. So this is 1600. What would half of 1600 be? It would be 800, right? It would be 800. Is this what I got over here? No, I got 400. So wait, what is 400 out of 1600? Well, we can simplify this quickly enough. Okay, so when I wrote this as 4 over 1600, I can easily drop off the zeros and get 4 over 16. 4 over 16. When I simplify that, I see they both have a greatest common factor of 4. Divide 4 out of both, I get 1/4. This smaller circle is 1/4 the size of this bigger. That means I could put 4 of this smaller circles into the larger circle. Now remember, this may not be to scale because it's my doings. Or I could say this one is 4 times the size of this. So please be aware, it's not about double just because this number is twice this number when you're looking at radius. And if you're looking at the diameters, 80 is twice 40, but it doesn't mean that it's going to be twice the size. When we start squaring things, we see that it's going to be 4 times the size or 1/4 the size. Okay? Um, I guess our word, since I haven't given you one yet, will be Western Farms. Okay, thank you very much.